Okay, let's dive in. We're talking about Schrödinger's cat today. You know, the one, that famous, maybe infamous thought experiment?
Right, the cat in a box that's supposedly both alive and dead until someone looks. It's a classic.
A total mind bender. But there's new thinking, new research suggesting that whole alive and dead interpretation, it might be logically inconsistent.
Exactly. Physically untenable, even. We're going to unpack why the cat is not actually both alive and dead simultaneously.
And instead, we'll explore these ideas of entangled flows and informational uncertainty. Sounds complicated.
It shifts the perspective quite a bit. It's a different way to frame the whole paradox.
Okay, so our mission today, figure out what this means for, the cat. How does this new view change the picture? Let's get into it. So first off, what's the main problem with the cat being, literally in two states at once? That superposition idea, it always felt weird, didn't it?
It did, and for good reason.
Yeah.
The argument is that it fundamentally clashes with, well, information theory, for one, and just macroscopic physics.
Macroscopic physics, meaning, like, big things, like cats.
Precisely. A cat is a huge, complex system. It's made of countless particles, all interacting. The idea that such a large object could maintain a delicate quantum superposition, like being both alive and dead.
It just doesn't scale up from the quantum world.
It seems highly unlikely, and that's where something called decoherence becomes really, really important.
Ah, decoherence. Right, I've heard that term. How does that play into this?
Well, decoherence is basically the interaction of a quantum system with its environment. And those interactions, they force the system to sort of choose a state very quickly.
So even inside the closed box, the cat isn't isolated.
Not at all. Think about it. There's air in the box, right? Temperature fluctuations. The cat itself is breathing, moving. It's constantly interacting with its environment.
And those interactions force it to be either definitely alive or definitely dead, almost instantly.
That's the idea.
Oh.
Any potential superposition would collapse extremely rapidly due to these environmental interactions. So no lingering state of being both.
Okay, that makes sense physically. So if the cat isn't physically in two states, what is going on before we open the box? That's where these entangled flows come in.
Exactly. This newer perspective introduces this concept. Think of entangled flows as interconnected streams, not just of physical stuff, but of information or maybe influence.
Streams of influence. Okay.
In the Schrödinger setup, you basically have three key flows that are dynamically linked together.
Three flows. What are they?
First, the quantum flow. That's the decaying atom, the trigger. Second, the macroscopic flow. That's the cat state, alive or dead.
Okay, atom and cat. What's the third?
Crucially, the observer flow, which is you or whoever opens the box. But these aren't just separate things happening in sequence.
They're connected, interacting.
Constantly exchanging influence, where you could say information.
Yeah.
And the poison mechanism.
Yeah, the poison vial linked to the detector.
It's not just a physical link. It acts more like an internal observer or a mediator within the box.
An internal observer. How so?
It effectively takes the information from the quantum event, the atom decaying or not, and transmits that information directly to the cat's macroscopic state, continuously.
So the information about the atom state is already known by the cat state, even before we look.
In a sense, yes. The link is already established. So the cat isn't in a physical superposition. It's in a state of what this research calls informational uncertainty.
Informational uncertainty. Okay, unpack that. That sounds different.
It means the information about the cat's state, alive or dead, exists and is determined, but you, the external observer, just don't have access to it yet. The uncertainty is in your knowledge, not in the cat's physical reality.
Ah, so it shifts the weirdness from the cat's physical being to our lack of information about the cat.
Precisely. You opening the box doesn't collapse a physical superposition. It resolves your informational uncertainty. You gain the information that was already determined within the system.
That actually seems a lot less paradoxical. It avoids that whole cat being two things at once problem.
It does. It aligns better with decoherence theory. The cat settled into a state quickly, and it respects the idea that macroscopic objects don't typically exhibit quantum superposition.
So it reframes the whole experiment, doesn't it? It becomes less about a physically impossible cat.
And more about the flow of information, the role of observation, and maybe the limits of applying quantum weirdness directly to our everyday world. It's almost more of a philosophical probe.
Right, a tool to think with rather than a description of reality. Okay, so let's try and wrap this up. This deep dive, it seems, shows us that Schrödinger's famous experiment maybe isn't really about a cat being physically alive and dead simultaneously.
Exactly. It's about something quite different when you look at it through this lens of information theory and these entangled flows.
Applying those concepts shifts the whole picture.
It does. The cat's state changes from this baffling physical superposition, which seems impossible for something cat-sized, to a state of informational uncertainty.
Meaning, we just don't know yet.
We don't know, but the outcome is already set within the box's interacting systems. It's neither definitively alive nor definitively dead to us, the observers, until we look. This resolves the paradox in a way that fits with physical reality.
It really reframes the whole thing, makes it less of a literal physics puzzle and more of a philosophical instrument.
A very powerful one for exploring how quantum ideas relate to the world we experience.
Which kind of leads to a final thought, doesn't it?
It does. And this is really a question for you listening right now. If we can take such a classic foundational thought experiment like Schrödinger's cat and completely reevaluate it using a new framework like information flow, what other deeply ingrained scientific ideas or even philosophical assumptions might be due for a similar reexamination? What concepts out there might look totally different if we approach them with a fresh perspective or new tools? What stands out to you?